We'll take a look at a few of the 10 scenarios for this independent samples t-test. To begin, we'll click on the Start button. So for this first scenario, we're asked to compare the means between two groups, both distributions fairly normal, equal variances are assumed. The null hypothesis is that the mean for the first group is less than or equal to the mean for the second group. We take a look at the evidence, and it's the exact opposite. The mean for the first group, of 54.56, is larger than the mean for the second group. That is not what the null hypothesis said. It's actually consistent with the research hypothesis. It looks like we may be able to reject the null, but first, let's make sure that this difference is statistically significant. We look at the t-test. It's a 1.74, so that's looking fairly good. Degrees of freedom is 46. And the p-value, if this had been a two-tail test, would be 0.090. Now we're doing a one-tail test, so we're going to divide this p-value two-tail test in half. So with the calculator, we could put in 0.09 and divide it in half. We'll get a 0.045, which is less than or equal to our alpha level of 0.05. So we'll reject this null hypothesis. For this next scenario, the null hypothesis says that the mean for group 1 is less than or equal to the mean for group 2. And indeed, the evidence is consistent with the null hypothesis. The mean for group 1 was a 47.08, and the mean for group 2 was a 56.05. I don't have to look at anything else. Because the results are consistent with the null hypothesis, we'll retain it. For this next scenario, it's a two-tail test. The null hypothesis is that the mean for group 1 is the same as the mean for group 2. The research hypothesis would be that they differ. The mean for group 1 is a 29.63, and the mean for group 2 is a 49.9. So it looks like a big difference, but we need to see if it's statistically significant. So we take a look at the t-test statistic. It's a negative 2.42. That's looking pretty good. We go down to degrees of freedom, 17, and the p-value for a two-tail test is 0.027. This is a two-tail test, so we know that 0.027 is less than or equal to our alpha level 0.05. We will reject the null. Okay, here the null hypothesis says that the mean for group 1 should be less than or equal to the mean for group 2. The evidence is the exact opposite though. The mean for group 1 is larger, it's a 73.22 compared to the mean for group 2, a 61.96. So we'll go down and look at the t-test statistic, and it is a 1.87, that's looking good there, degrees of freedom 64, and the p-value for a two-tail test is 0.066. Now, again, this is actually a one-tail test that was done. SPSS always gives it to us as if we're doing a two-tail test. In this case, we could either divide this two-tail test in half, so that instead of being 0.066, we would be 0.033, and that's less than or equal to alpha level of 0.05, so we can know, hey, we can reject it. Another way of conceptually doing the same thing is instead of dividing the p-value two-tail in half, we could just compare it to 0.1, right? 0.1 divided in half would be 0.05. So anything that's 0.1 or less would allow us to reject the null. So that's two ways, but if you're uncomfortable with that, just divide the p-value two-tail in half anytime you're doing a one-tail test. And again, that turns out to be 0.033, which is less than our alpha level of 0.05. So we will reject the null. Okay, here our null hypothesis says that the mean for group 1 is going to be larger than the mean for group 2, and the evidence is consistent with the null hypothesis, so we retain. In this next scenario, the mean for group 1 is supposed to be less than or equal to the mean for group 2. It's a one-tail test, and the evidence is consistent with, no, actually, the evidence is inconsistent with that. Mean for group 1 was larger. So that means it's worthwhile to take a look now at the t-test statistic. The mean for group 1 was a 40.9, mean for group 2 is a 31.64. That's a difference, but is it statistically significant? T-test of 2.01 is looking good there. The degrees of freedom is 74, and our p-value for a two-tail test is a 0.048. Divide that in half, we get 0.024, and that's less than or equal to our alpha level of 0.05.